Okay, guys, we're going to do section 14.2 and 3 quickly. I'm going to go through both of them in this lecture. So we're talking about transformations. We talked about translation, which is basically like a slide. And then in 14, this is supposed to say 14.2, reflections and glide reflection. So a reflection is like a flip. Like think of a butterfly, the reflection, each side is a mirror image of the other. Or when you look in the mirror, that's a reflection. When you take a selfie, it's a reflection. Um, so let's look at what that looks like. So here is an example. We have a tree. We reflected it across a vertical line. And so then we see that other image on the other side. You can also use um, this as a device that helps you reflect images like that. This is just showing you another example. If I had tracing paper, you could fold over a line and then trace it onto the other side. That would be a reflection. This is drawing a line of reflection, which you can think of as a line of symmetry. So this line N is the line of reflection for this triangle ABC. This, okay. So if I wanted to reflect A14 across that line, y equals x, 1, 4 would become 4, 1. So if we're reflecting across this line, basically it means these guys switch. So this line reflects over here. I mean, that point reflects over here. And so the x's and y's have flip-flopped. The same here with the b. Negative 3, 0, 2, 0, negative 3. And this is just sort of reflecting in another way across the surface with a ray. Let's see. A glide reflection is when you have those two things put together. So it's like translated. So it's like a shift, and then it is reflected. So it's like a slide and then a reflection. So C3 is a glide reflection of C1. It is possible the isometries are congruent. So ABCD is a rectangle to describe a sequence of isometries to show that ADC is congruent to CBA, ADC congruent to CBA. So basically, if you've done these transformations with just the translation and a reflection, then the figures are congruent. So they're saying one way to describe that these are congruent is if I took this guy and I did a half turn with this as the center, it would be this. So that is a rotation, and it proves that those two are equal. Another way is a reflection. So reflection through this line, and then a reflection of ADC is a line passing through E. So that's another way that they could be seen as congruent. Now let's go to section 14.3, the last one on transformations, and this is dilation. Now dilation is not a congruent transformation because dilation, you think of like getting your eyes dilated at the doctor, your pupils get larger. So dilation is a change in size. So by a certain scale factor. So this is showing dilation of this image to that size here. Here's an example where this triangle is kind of being blown up to be this triangle here. And then this is talking about the scale factor. So it's possible to define a dilation when the scale factor is negative in the same way as the preceding definition. So if the scale factor is negative, it means it's getting smaller. Find the image of the quadrilateral of ABCD under a dilation with a center 0 and a scale factor of 2/3. So here we're taking this and we're shrinking it down by 2/3. Let's see. If we want to identify the scale factor, we can take the length and the side. So here AB is 5. Oh, no, it's not. It's 5 minus 1, so that'd be 4. And AD is 2. And then it can compare these sides over here. This is 7 minus 1, so that's 6. And AC is 1 1, so that's 3. And so if I divide those, they're both give me that ratio of 2. So you can see that that's this fill factor. Perspective drawing is a way to think about dilation. And if you ever took an art class where you had to draw a road and you thought about like there's a point on the hill and then this is a perspective image, right? So the idea that it's getting smaller in the distance and wider up as you get closer. And so this idea is a way to think about dilations as well. And then here's just a few examples. It says, show that ABC is the image of APQ under succession of isometries with the size transformation. So we rotated it and then we dilated it with a factor of 2. And then let's see. They're similar if and only if it is possible to transform one onto the other by an isometry, followed by a dilation. So that's just another way to think about similarities. And again, dilation means that the size is changing. So I have a rectangle, and then I'm making it bigger or making it smaller. I didn't want to change the proportions. So the idea of dilation is that it's getting smaller or bigger. And then we had the beginning, the translation was a slide. The reflection is, if I flip this over, let's see, I'm gonna flip it, I think so, flip. That'd be a reflection. And then rotation we talked about when we rotate around. And then also the dilation. So those are all the different types of transformations that we talked about in this last section. And hopefully that will help you do your assignment. Reach out with any questions you have.